Hi, my name is Christopher, and in this module you will get an introduction to the 7 main AM technologies. Let's have a look at the agenda for this module. First, we will look at an overview of the most common additive manufacturing technologies. We'll go through a 4-slide introduction for each basic technology that is going to cover the technology itself, the materials, the pros and cons of the technology, and the leading machine manufacturers. Then finally, we will have a look at the technology maturity and industrial landscape. Here we have an overview of the 7 general technologies. First we have vat photopolymerization, also known as VAT. Then we have material extrusion, material jetting, binder jetting, powder bed fusion, direct energy deposition, and sheet lamination. We'll be going through each of the subcategories of these 7 general technologies. First we have the VAT technology. The VAT technology originated with the SLA process, also known as stereolithography. The process works by having a UV light curable resin in a bath. A laser source is applied to the resin and cures the resin locally. This is done layer by layer, as we can see here in the following video. We first fill up our resin, and we then apply our laser layer by layer, slowly building up our part one section at a time. The DLP process, or digital light processing, is very similar. However, we are using a projected UV light instead of a laser. This means that we can process an entire layer at a time, and the process is typically faster. CDLP, or continuous digital light processing, is similar to DLP. However, the process platform is continuously moving, and we build our part as we go. The VAT technology utilizes a range of materials. You can print everything from elastomers to transparent material, and also for dental applications. Here we have an overview of the pros and cons of the VAT process. The pros include good for prototyping, it is quick to print, and you can obtain a surface finish all the way down to 10 microns. Some of the cons include the parts being brittle, and since they're reacting to UV light, they will react to sunlight, and that leads to a loss of mechanical properties. Then there is also extensive post-processing required. Let's have a look at the leading machine manufacturers for the VAT process. For SLA, we have Formlabs 3D Systems and DWS. For DLP, we have B9 Creations, SprintRay, and for CDLP, we have Carbon and EnvisionTEC. Now we will move on to the material extrusion process. The material extrusion technology is most well known with the FDM method, or fused deposition modeling. The way it works is that you have a polymer material on a material spool. The material is extruded through a heated nozzle and deposited on top of your build platform. Layer by layer you will be building your object. There are typically 4 configurations. The first and most well known is the Cartesian 3D printer. As we can see here on the short video, we have a build platform that can elevate in the Z direction, and we have a nozzle that can move in the X and Y direction. We can then slowly build up our part like this. Then we have the Polar 3D printer. Here the platform moves while the nozzle is steady. The third configuration is the Delta 3D printer. Here the nozzle is being controlled using 3 linear actuators, and the material is being deposited on a steady platform. The final configuration is the Robot Arm 3D printer. Here you are simply using a robot arm to control the deposition of the material as it is being extruded through the nozzle. Let's have a look at the materials used for material extrusion. We have here divided it into commodity materials and engineering materials. The main commodity materials include PLA, which is easy to post-process and has good heat resistance. Then we have ABS, which is known for great stiffness and durability and a variety of colors. For the engineering materials, we have Onyx FRA. Here we can use carbon reinforced nylon, which is flame retardant. We also have Fibrex nylon with, in this case, 30% of glass fiber. This is simply glass reinforced nylon that has excellent mechanical and thermal properties. Let's have a look at the pros and cons of the material extrusion technology. The pros include the technology being cheap. It is great for prototypes, and it is great for beginners. Some of the cons include support being required in some cases. The properties are anisotropic, and you will obtain a poor surface finish. The leading machine manufacturers within material extrusion includes Stratasys, Ultimaker, Markforged, and MakerBot. Let's have a look at the material jetting technology. The material jetting technology can be divided into three sub-technologies. First being MJ, or material jetting itself. This is the main industrial technology. Then we have NPJ, or nanoparticle jetting. This is using particle-infused liquid and heat to evaporate the liquid. Then we have DOD, which is drop on demand. It uses two print jets, one for building material and one for support material. The technology works similar for all three cases, and we here have a video demonstrating how the material jetting technology works by depositing material and using a UV light to cure the material as we go. Let's have a look at the available materials. Here we have a view of the PolyJet materials, and that is Stratasys' version of the material jetting technology. We can see that there is a wide range of polymer materials, all the way from 2003, where they developed a rigid material called RGD 720. Through the years, they have developed different kinds of materials. In 2011, they developed a clear material called VeroClear. And we can see that after 2016, they have developed a full color realism material. If we have a look at the pros and cons of the material jetting process, we can see that we can obtain a great surface finish. It is considered the most accurate 3D printing technique, with dimensional tolerances going all the way down to 0.02 millimeters. We can also have multi-material combinations. Some of the cons includes that the parts are often brittle and the material properties are generally not the best. Finally, both the machine and materials are quite expensive. The leading machine manufacturers for material jetting includes for material jetting, Stratasys and 3D Systems, for nanoparticle jetting, XJet, and for drop-on-demand, SolidScape. Now we will move on and have a look at binder jetting. If you have a look at the binder jetting technology, we can see that it is subdivided into two technologies. One being BJ, or binder jetting, and the other being MJF, or multi-jet fusion. If we have a look at the process for the binder jetting technology, we can here see how we are applying a binder to our powder. After having applied the binder, we are heating up the binder to cure it together with the powder particles. After it being cured, we have what we call a green part. The green part then needs to go through a debinding process where we will obtain our brown part. It is very brittle in both of these conditions. Finally, we will move our brown part into a sintering process where we will sinter together our powder particles, obtaining our final geometry. The multi-jet fusion process is very similar to the binder jetting process. However, we are using polymer instead of metals. Here we are in one continuous motion, both applying the fusion agent and heat to fuse together the part. If we have a look at the available materials for the binder jetting technology, we can see that for binder jetting itself, we have a wide range of alloy metals. We can also use ceramics, and we can even use ceramic metal composites. For multi-jet fusion, it is a wide range of polymers that are available. Let's have a look at the pros and cons of the binder jetting process. We have fast production of parts, we can obtain high layer resolution, and the as-built surface finish is all the way down to 6 micron. Some of the cons include, specifically for binder jetting, that the parts are fragile in both green and brown state. The debinding process is highly labor intensive, and the parts will shrink in a non-uniform manner and all the way up to 27%. The leading machine manufacturers within binder jetting are X1 and Digital Metal for metal binder jetting. For ceramic binder jetting, it is 3D Systems and VoxelJet. And for multi-jet fusion, we have HP. Now we will move on to powder bed fusion. The powder bed fusion technology can be subdivided into three main categories. SLS, known as selective laser sintering, SLM, known as selective laser melting, and EBM, known as electron beam melting. The principle behind all three subcategories are the same. We are either applying a laser or electron beam to a powder bed of powder. The powder can be either polymer, which is used typically for selective laser sintering, or metal, which is used for SLM and EBM. We here have a video showing the SLM process. We can see how we are applying our laser to the powder bed. We do this one layer at a time and build up our part. In essence, the technology is very similar to SLS and EBM. Let's have a look at the available materials for the powder bed fusion process. For SLS, we are working with polymers, and we can use everything from PA12 to PA with fillings such as carbon, glass, or metals. For SLM, we work with metals. Here we can use everything from stainless steel to Inconel, aluminum alloys, and even precious metals. The EBM process is very similar, and we can also use stainless steels, titanium alloys, and even alloys such as cobalt chrome. The pros and cons for the powder bed fusion process includes that you can create complex geometries. It is ideal for functional parts. For the SLS technology, you will not require any support. And the SLM and EBM technology both provides great mechanical properties. Some of the cons includes that you will have a grainy surface finish on as-built parts. The feature resolution is not the best. However, SLM is better than EBM, which is better than SLS. And it is also prone to warping in large flat areas, except for EBM because it is being processed at a very high temperature. For both SLM and EBM systems, there is a big con that they are very expensive. The leading machine manufacturers within powder bed fusion is for SLS, EOS and 3D Systems. For SLM, we have EOS, Concept Laser, Renishaw, Trumpf, DMG Mori, Premier Additive, and SLM Solutions. For EBM, we have Arcam EBM and Geo. We will now move on to directed energy deposition. Directed energy deposition can be subdivided into three main categories. First being LENS, known as Laser Engineering Net Shape. Then we have EBAM, known as Electron Beam Additive Manufacturing. And then we also have WAM, Wire Arc Additive Manufacturing. The basis of the technology is that you're using either a laser beam or electron beam to melt powder or wire as it is being deposited on a substrate. The wire arc additive manufacturing process is very similar. However, here you are applying a current to your deposition nozzle and substrate, which creates an electric arc between the two, which can melt the material as it is being extruded. If we have a look at the process of the technologies themselves, we can here see how the LENS process works. We are applying our powder together with a laser, allowing us to build up our part. The EBAM process works similarly. However, here we are using a wire to deposit, and we have an electron gun out of view in this video. Finally, we have the WAM process, which is using the wire arc melting to deposit a wire as it is being extruded, and we can see how we can quickly build up a bathtub-like structure. The available materials for directed energy deposition include stainless steels, titanium alloys, Inconel, aluminum alloys, and even copper. If we have a look at the pros and cons of the directed energy deposition process, we can see that you will obtain good mechanical properties. It is cheap compared to other metal AM processes, and it is great for large structures, as well as excellent for repairing. Some of the cons include the obtainable tolerances being relatively poor. It is not ideal for prototyping, and you will have a highly rough surface finish. The leading machine manufacturers within directed energy deposition includes for the LENS technology Optomec, Beam, and Premier Additive. For the EBAM technology, it includes Skiaki, and for WAM, it is Ramlab and MX3D. Now we will look at the final of the 7 main technologies, namely sheet lamination. For sheet lamination, the specific technology is known as laminated object manufacturing, or LOM. The technology works by having a foil supply of either thin metal or paper. A heated roller is being rolled across the foil, ensuring that it is bonded towards the lower part of the object that you are building. Afterwards, a laser is cutting up your piece to ensure that only the area of interest is being left. The process is also possible to use for paper with color, and after having built up your paper part, there are some manual processing removing the layers that are not needed. The most commonly used material for sheet lamination is standard paper, but we can also produce structural parts by using fiber-reinforced sheets or rollable metal sheets. Let's have a look at the pros and cons of the sheet lamination technology. The pros and cons includes that the materials are cheap and the production costs are low. You can create large parts and you don't need any support. However, some of the cons includes that you cannot produce complex geometries, the printers are relatively expensive, and you will only obtain a poor surface quality. The leading machine manufacturers for the sheet lamination technology are originally Helicis and EMCOR. Helicis has since been succeeded by Cubic Technologies, and EMCOR has been acquired by Clean Green 3D. Now we will have a look at the technology maturity and industrial landscape of metal AM and polymer AM. Let's first have a look at the maturity of the AM polymer technologies. All of the technologies that we covered, including VAT, filament-based material extrusion, powder bed fusion, and material jetting, are all in the top right corner, which means that they are used for widespread industrial use or industrially in general. If we have a look at the metal AM maturity index, we can see that the SLM technology has industrial widespread use. The lens technology, EBM technology, and WAM technology have industrial use, and finally both EBAM and binder jetting are in the category first applications. If we take a look at the metal additive manufacturing technology landscape, we can see that there is a wide range of different technologies not being covered in this module. At DTI, we are focusing on binder jetting and laser powder bed fusion, where we have in-house industrial production using SLM machines. The polymer additive manufacturing landscape is very similar. We can see that there are many more technologies than we have covered in this module. And at DTI, we are focusing on powder bed fusion, where we are using SLS machines for in-house industrial production.